When we think about renewable energy, solar power undoubtedly comes to mind. Picture this. Endless rows of shimmering solar panels, each one capturing sunlight and transforming it into electricity. By the end of 2023, solar panels spanned over 10,000 square kilometers of our planet, producing around 1,600 terawatt-hours of electricity annually. That's roughly 6% of the world's total power output. This green energy source is not only environmentally friendly, but it's also a gift from nature. Unlimited, renewable, and free. But here's a catch. Current technology isn't efficient enough to convert 100% of sunlight into electricity. Today's mainstream solar panels are made from silicon, which converts only about 22% to 24% of sunlight into usable power. So, if a solar panel receives 100 watts of sunlight, it only turns 22 to 24 watts into electricity. But why is this? Let's break it down. For a solar panel, the key unit responsible for turning sunlight into electricity is a solar cell. These silicon-based cells are affordable and widely used, with a theoretical maximum efficiency of around 29%. However, in real-world conditions, limitations like material defects and manufacturing processes prevent us from reaching their full potential, and we rarely exceed 26% efficiency. So, how can we make solar energy more efficient? That brings us to a new material that's sparkling excitement in the field: perovskite. The original perovskite is a mineral called calcium titanium oxide. A Russian mineralogist called Perovskite discovered it. The name perovskite has since become a generic term for substances with a similar crystalline structure. Perovskite is a material with a unique crystal structure that showed impressive potential for solar applications. Scientists have discovered that perovskite can absorb a wider spectrum of sunlight, especially in the visible light range. In fact, since it was first introduced in 2009, perovskite solar cells have seen a rapid rise in efficiency, from 3.8% to 28.2% in the lab, and theoretically it could reach up to 33% for single-layer cells and even 45% with a dual-layer structure. One promising application is the tandem cell approach, which layers perovskite on top of silicon. Perovskite is great at capturing visible light, while silicon works well with infrared. Together, they maximize the amount of light converted into energy. In mid-2024, China's Longi Green Energy announced a new tandem cell with a record-breaking efficiency of 34.6%. Another big advantage of perovskite is the abundance and easy synthesis of its raw materials, which makes large-scale commercialization very feasible. Perovskite minerals can be found in nature. In recent years, scientists have developed synthetic perovskite tailored for solar energy. This synthetic process has a lot of material options, and they are mostly cheap and abundant elements, like lead, iodine. Moreover, here's a major production benefit. Perovskite has a much shorter manufacturing process. Unlike silicon, which requires highly purified semiconductor material, perovskite can be synthesized even from lower purity materials, which reduces costs and complexity. After initial processing, perovskite materials can be directly assembled into solar components, greatly shortening the overall production time. In contrast, producing silicon solar cells requires a four-step process. Now, you might wonder, If perovskite is so great, why aren't we seeing it everywhere yet? Because there are still a few challenges. First, stability. Perovskite is sensitive to temperature, humidity, and light fluctuations, meaning it can degrade in damp or hot environments. If a solar cell's efficiency drops drastically after just a year or two, it won't be practical for large-scale deployment. Another issue is lead. To achieve high efficiency, perovskite cells currently rely on small amounts of lead, which could pose environmental risks. Scientists are working on lead-free alternatives and more robust recycling methods, which could make perovskite cells safer for the environment. Around the world, many companies and research institutions are dedicated to overcoming these challenges, pushing perovskite technology closer to commercial reality. So, will perovskite cells become the future of solar energy? Only time will tell. For now, it's a promising advancement, and we'll be watching closely to see what breakthroughs come next. Okay, thanks for your watching. See you next time.